This was probably AI. I can guarantee you this talk is 100% AI free. I'm French, so my first name is Nicolas. It's written with an S because we like to have extra letters, as you know. Thanks to be here for this talk, especially after the lunch break. I will be talking about OpenTelemetry. Who I am? I think it's not the first time I come here. Actually, I'm pretty sure it's the third time. Who was already at one of my talks? Ooh, good. For 17 years, I was a consultant in different roles, from developer to solution architect. For the 7 last years of my life, I've been a developer advocate, which means I was paid to go to conferences, to have beers, and now I'm getting back to software engineering. So, as you can see from my gray hair, I'm old, I have experience, and in the past, what we did was not observability. What we did was just monitoring. Monitoring where a bunch of people sitting in front of a big screen, or in general, a lot of small screens, because at the time we didn't have any big screens, and they were looking at dashboards. And when something like peaked or whatever, then they could log into the machine and try to fix the situation. The problem is that doesn't work anymore because we have more and more systems, and the systems are becoming more and more distributed. And I'm on purpose avoiding the word microservices, because a lot of people are doing microservices without any reason, but a lot of people are doing distributed system because, well, it's necessary. So I try to avoid to use the word microservices, and I will use the word distributed system. So because monitoring couldn't handle the current practices, we came with a new concept. I'm a big fan of Wikipedia definition. This one, unfortunately, forgets something very important. So they talk about distributed systems, which is good, but they talk only about logging and tracing. And now I need to find the, logging and tracing. Whereas the 3 pillars of observability are metrics. Remember the guys who are in front of the screen? They were looking at dashboards of metrics. Logging and tracing. This talk is focused on distributed tracing, but I just want to have a couple of slides about metrics and logging because I think there are some important notions that belong together. The first is everybody does metrics nowadays. Who doesn't do metrics? Who doesn't have dashboard of metrics? Yeah, everybody does. However, you would benefit from having higher level metrics. Like, your business doesn't care that much about your hard drive storage, how full it is. They don't care. That's not their problem, that's your problem. What they care about might be, if you're in e-commerce, the number of orders per second, the number of orders in the last hour, the number of 404 or 500 or whatever. This could give them insight into the application, what they care about. And I'm pretty sure that if you give them this information, you might get budget. And it's very hard to get budget. Because if you tell your business, hey, give me budget because I want to know how full or how much CPU is used, they will just look at you and say, yeah, thanks. If you give them what they want, you scratch my back, I scratch yours. Logging is a bit harder already. At one point, I had a talk completely dedicated to logging. So here is, or in 2 slides, what I had. The first thing is what to log. When I was a young engineer, I thought I was smart. Now I know better. But I thought I could solve the problem of logging, because my experience was that some of my colleagues, including myself, were very, very careful about logging. We logged correct information at the right place, but some of my colleagues didn't give a crap. So either they didn't log at all, or they logged the wrong information or at the wrong line. So basically, when you read the log, some parts were very nicely written, and some parts you had no clue what happened. And I thought, oh, I will be smart. I will create a Java agent. So I'm a JVM engineer, so I will basically create a Java agent that would intercept each method execution, and at the beginning of the method, I will log the parameters, and at the end of the method, I will log the return value. That was super smart. No, you don't believe it. Yeah, because I realized a bit too late that, hey, passwords could be parameters. So it's not, it was a great idea, but I hit the wall of reality. It's not as easy. So I came back to trying to convince my colleague to improve the way they were logging. So there is no other way than when you do a code review, you look at the maintainability of the code, but please also have a care about the logs. The logging format, we have been using readable logs for ages, because again, at the time, when something happened, you would locate the machine, and you would log into the machine, and you would read the log file, and you would have insight into the problem of what happened. The problem nowadays is, well, first, as I mentioned, there are multiple machines, so you don't know which machine to log into. And the second problem is when you are using containers, which is probably now the majority of organization, the container might be dead already. So there is no more machine to log into. So in order to cope with that, you have a distributed logging system, a centralized logging system where you send your logs. And in which format are you sending your logs? Unstructured text, readable for human. What does the centralized logging system needs to do? Well, parse everything to structure it into its database. Why don't you write JSON directly? Who is writing directly JSON? Oh, that's better. No, really, that's perhaps between 5 and 10 hands. That's really good. Easy peasy, tomorrow you get back to work, write your logs in JSON. You will remove one component that is dedicated to parsing, which is fragile, costs time and money. And your organization will be better. That's what you want, right? Where to log? Well, as a young engineer, a young Java developer, I was taught you should never, ever write to the console. You should always write to files, because then we can rotate the files, and then we can archive the files, and blah, blah, blah. And now you are using containers. Where do you log? On the console. You shouldn't use file. It's crap. As an architect, also, you need to think about the benefits. Scraping the logs versus sending the log. Is it push or pull? There are benefits on both sides. Think about how long you should store the logs. If you are in the banking industry, perhaps storing long-term shouldn't be in the logs, but probably on Kafka or whatever. Then think about searching and displaying. Here are a couple of centralized logging systems that most of you are familiar with. I've mainly used Elastic, but yeah, they all work. Now comes the third pillar. Third pillar is the hardest one. Who is already doing distributed tracing at the moment? 3, as many as JSON logging. That's cool. Not the same, but about the same number, like 5 hands. Again, Wikipedia definition that I don't like so much, so I came up with my own, which probably was not my own. I read it somewhere, I improved it, I changed it, blah, blah, blah. The idea of distributed tracing is to follow a single business request across all your distributed components. Because if something fails, we want to know where. And if there is a performance issue, we want to know where. And this is actually not a super new idea. We had already had pioneers doing that perhaps 5 or 8 years ago. Who knows about Zipkin? Yeah. Jaeger? Yeah. Open tracing? Forget about open tracing. I will tell you afterwards why. It's not a bad product, it's not there anymore. So the problem when you have such actors, which are all their proprietary technology stack, is when you decide on the stack, then you limit yourself to only libraries or SDKs or frameworks that actually support the stack. You're limiting the option for distributed tracing. That's not great. When I choose a component, I want to have as many choices as possible, to implement as many business requirements as possible in the least expensive way. I'm lazy. If you are limited by your stack, it still works, but of course, you might not choose the best of breed. So in that case, what do? Well, you have 14 standards, here only 3, but you had 14 standards, and you create a standard to unite them all. And as the XKCD comic, now you have 15 standards. So in order not to fall into this trap, you need to have a strong organization to actually implement the standard, or at least define the standard. In that case, it's about W3C, which created the standard called the trace context specification. Who knows about the trace context specification? 2 hands. Who read the trace context specification? Oh, 3 hands. Half. Come on, it's very short. You didn't read it, okay. Okay, actually, I encourage you to read it because even I couldn't understand it. It's very, very easy to read. Basically, it defines an HTTP header, which will carry different metadata about the trace. And you should carry this HTTP header across all calls, enriching it, changing it, whatever. And that's how you can make a distributed trace. And the idea in this document, there are 2 main concepts. The first is the trace. The first is the trace. The trace is a single business request that goes across the components. And it's a span. A span is something that happens in one of the components in the context of the trace. Obviously, there must be at least 1 span per component, otherwise the component is not part of the trace, but there can be multiple spans. And it looks a bit abstract, but it's quite easy to grasp. So here you have a single trace that goes across 3 components, X, Y, and Z. And then you have span, something that happens inside the component. A span is bound by a parent-child relationship, or I should say a child-parent relationship, in that a span should have 1, or in the very specific case of the first span, 0 parent, and the span can have as many children as it can. Basically, you can have parallel execution in the children's span, so you can have as many children as you want. So that's the idea, and as developers, you could write your own code to actually capture the HTTP header, parse the different information, the trace ID and the span ID, create a new span ID yourself, attach it to the trace ID, create a new HTTP header, and forward it to the next component. Who here is a software developer? Okay, Ops, DevOps, whatever that means for you or for your organization. You are both, you are Ops and DevOps. Yeah. So basically you are DevOps and you don't know what it means. You're like, I agree, I understand. Sorry? Yeah, I can understand. So if you are a developer, you are lazy by nature, let's face it. So why, yeah. I saw the guy, yeah. It's a benefit, actually. If you are like smartly lazy, it's a really good benefit. I am lazy. I hope in a smart way, I don't know. The idea is you could do everything by yourself, but I prefer to have a library, a SDK, a framework. Do it for me. Comes OpenTelemetry. And OpenTelemetry and the trace context specification are a Venn diagram that are not aligned. Basically, trace context is only about tracing. OpenTelemetry is about logs and metrics and traces. So they do more, and they are implementing all that crap that you don't want to do yourself. So you can have a library, a SDK, or whatever that actually generates the OpenTelemetry data so that you don't need to do a lot, or sometimes nothing. So as I mentioned, it implements the trace context specification. I mentioned open tracing that you should forget. So it has been superseded by OpenTelemetry. So it has been the merge of two projects, which is very good because it happens very rarely in the open source world. It's a CF project. It has lots and lots of followers of GitHub. I tend to refer to OpenTelemetry as a black hole that attracts all the actors in the industry. So nowadays, if you have a product that's not OpenTelemetry compatible, you won't be very successful. As I mentioned, you have instrumentation, and here you have like components that produce OpenTelemetry data, and everything flows into one or many OpenTelemetry collectors. The OpenTelemetry collector is not part of the 3.3c trace context specification. It's just a component that is offered by OpenTelemetry so that it can collect OpenTelemetry data. What happens after the collector is not of OpenTelemetry's interest. That's up to you. Basically, the OpenTelemetry collector, you can filter. It's a proxy. You can aggregate data. You can filter out data. You can enrich data. You can do a lot of things and store it somewhere. And again, as I mentioned, what happens after here, nobody cares. So it's up to you to decide afterwards where you will really store the data, regarding the fact that, hey, you need storage, which perhaps you want to store it for a long time, it costs money, and so. Sometimes you want performance, sometimes you want to be cost effective, whatever. So OTel provides a collector, but the legacy actors, they changed their backend to also be OpenTelemetry compatible. So as long as you send them OpenTelemetry data on the right port, they will actually get the data. And now you are in a very comfortable position because if you're already using one or the other, you just need to open the port to ask your developers or your DevOps or your ops to change from whatever proprietary stack they were using to send OpenTelemetry, and you keep the same backend in the same storage and the same data, basically. It's just now you are using a de facto standard to send data. And from this position, you can change anything in infrastructure because it's all OpenTelemetry. So you can change from Jaeger to Zimkin or whatever. So they are mostly developers, and that's good because my talk is mainly like aimed at developers. How can you help your colleague, your ops or your DevOps colleague, get insight into your application, especially if you are a DevOps, because it means that you are helping yourself because you won't be called at 2 a.m., right? Or if you are, it will be a quick resolve and you will get the money for being there. Two ways. The first, zero code instrumentation. Zero code. I repeat, zero code. As lazy developers, it's good. I mean, you don't write anything. There is a catch. You need to have a runtime. So a runtime could be the JVM, for example. So as I mentioned, the JVM agent, you can actually change the code that is loaded into the JVM. So you would instrument the code with OpenTelemetry code. Python, very nice runtime. No runtime, well, you can have Kubernetes, you can also do stuff with it, but if you don't have a runtime and you don't run on Kubernetes, then you need to do it manually. For example, Rust, no runtime. If you want to use OpenTelemetry with Rust, you need to do it manually. You can also do a manual instrumentation if you want to have better control over the instrumentation. Like I will show you in the demo, you can have a lot of information by default with the zero code approach, but sometimes you want to do more. My advice is use zero code instrumentation when you can. First, again, because I'm lazy, but that's not the only reason. Because implementing OpenTelemetry might cost money, right? So Zero code instrumentation, you don't need to bother your developers. They can be oblivious. You do that at runtime. You don't tell anybody. You put a Jaeger as shadow IT in a server nobody knows about. You get data. Next time there is a bug, you use it, and afterwards you come back to your manager saying, look, this is how we solved the problem in 2 hours instead of 2 days. Now get me budget. And now it's time for a demo. As I mentioned, I'm a developer advocate, or let's say I was for the 7 last year, and well, we have a bad reputation because when you are a developer advocate, you are not a true engineer. Who thinks, well, first, who knows about developer advocates? Well, not that many people. Who thinks we are bad engineers? That's fine. I won't, now you're afraid, yeah. Okay. And so most of the developer advocates, they do hello world, and say, hey, it looks, and now it's up to you to have the whole. It's like, you know how to draw an hole. Yeah, you draw 2 circles, and then, oh, you draw the fucking hole, right? So I try to be a bit better, and this is my hello world. This is an e-commerce setting to display the home. Yeah, that's, yeah. You are suitably impressed, right? Yeah, that's good. That was the idea. So the idea is I have an e-commerce setting, and I have several components that display the homepage, and in particular, data for the products. So first, I have an API gateway, because you should protect your API with an API gateway. It forwards the request to my catalog. Catalog is a regular Kotlin Spring Boot app. Who is a JVM developer? Ooh, not many. Okay, that's good. I have other interests. Catalog gets the product, so description and name, but you probably need to have if the product is available or not, and in which warehouse. So for that, I have a simple proxy I've created in Rust and Axiom, and it calls different warehouses. The first one is in the EU, let's pretend, and it's Kotlin and Spring, but it's using GraalVM to create a native image. If you are not on the JVM, I won't describe it to you because it's not interesting. I have a warehouse in Go engine. Who is a Go developer? Sorry for you. I hate Go, but because it's very popular, I say, oh, I will create a stuff in Go. I have one in Ruby, and I have the one in Quarkus on the JVM in Java. And then I also need to have the prices. So every one of them, they get the data from a Postgres database. I need the prices, and I have a Python Flask application for that. Who is a Python developer? Okay, I will describe the Python stuff. And because Python is slow, right, I have a cache in front. Don't hurt me, please. And I want also to show you how you can instrument something on Kubernetes. So I have this other Python application, which is made using Fast API. And then there is zero code instrumentation through Kubernetes. Who is using Kubernetes? Okay, I will show it as well. And at the beginning, when I did this talk, this demo went through several iterations. People asked me, look, I understand how you can like forward the HTTP header. That's very fine. How do, sorry, oops. How do I do that with asynchronous messaging? What if I have an MQTT queue or a Kafka queue, right? So I will show you how you can do it. The catalog will publish analytics, so basically data, I don't care, in an MQTT broker, and on the other side, I have a TypeScript Node.js application that subscribes to the queue, and it becomes part of the distributed trace. I will deploy everything on Kubernetes. So I have 2 clusters. The one is the real cluster, the host cluster called Hotel Infra. It has the API gateway, an OpenTelemetry collector, and Jaeger. And inside, I have a virtual cluster using vCluster, which deploy all my business stuff. It also has a collector. So basically, as I mentioned, what happens after the collector, nobody, well, it's not the problem of OpenTelemetry. So here, every cluster has its own collector, and both dump them into Jaeger. Shall we start? Good, thanks. So only one person is interested in starting. The rest, they don't care. Exactly. I won't use my famous Polish words because I'm recorded, but you can imagine what it is. So the first thing I do is I will create a new virtual cluster. And the second thing is I will create the Helm chart of the infrastructure. Then I will connect to the cluster. It takes a bit of time because it's creating the virtual cluster. So if I get back to this, here I'm creating this virtual cluster, right? And I'm creating the hotel infra here to deploy the Helm charts of whatever is in the infrastructure. And then, once that's done, I can deploy what's inside the virtual cluster. And it shouldn't work, yes, because I forgot to be here. And now it should work. Okay, everything is setting up. It's quite fast today. Of course, Ruby takes a bit more time. So we wait a bit. Oh, everything is green. Now I can curl to have a product. And I can check on Jaeger. So I'm using Jaeger. And here is my first trace. Amazing, right? Thanks. So if you want to have a high-level view of the system, of course, you can have this kind of DAG. I will put the DAG. So here you can see it starts with traffic. I have one request to the catalog. I have 3 requests to Jaeger all-in-one because it's also tracing the fact that I'm sending data. The catalog calls one time the pricing, one time the inventory, and the inventory calls the stock, blah, blah, blah. And that's crazy because as a system architect, you know, nowadays, who here is an architect or has architectural responsibilities? Yeah, not a lot of people. Yeah, the old people in general. So, yeah, sorry, I'm one, so I can be a bit sad about it. One of the problems you have is to understand the system. So when you start a position, you are shown tons of diagrams, and the problem is people tell you, oh yeah, but it's a bit outdated, right? And this one is also a bit outdated. And basically there is no source of truth. You need to build your knowledge of the system while working and making mistakes. This gives you at runtime the exact topology of the system. So if you are an architect, this helps you. Or if you want not people to learn about your system, so you only have the knowledge, you should actually not agree to have OpenTelemetry, because the people who know about that, they will challenge your position, right? Because now you won't be the only person to have the knowledge. So as I mentioned, you have the whole trace here, and you have at least one span per component. In some cases, you can have multiple spans. So here, traffic decided to have everything measured, like you have the entry point, the metrics, the router, the service, blah, blah, blah. Here, my catalog, you can already have some information. For example, here you see the HTTP request that is received. And on every span, you can have additional data. So you know that the client address was this one, the HTTP request method, blah, 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 blah. And you can also have information about the processes. how did I achieve that? So since there are a majority of Python developer, I will spend a bit of time into Python. Here on the PyProject.toml. So first, please excuse me, I'm really bad at Python. I know how to do a bit of stuff, but don't ask too many hardcore questions. What we can see on the dependency side, there is no dependency on OpenTelemetry, none at all. So basically the developers, they don't know about OpenTelemetry. They develop their stuff like directly, and you didn't bother them. That's a real benefit. So how do I add OpenTelemetry? Well, in that case, I do it during the build. If you are not using Docker, it will be at runtime, but here I'm using the container build. I install PostgreSQL, blah, blah, blah. I install the additional dependency that I need, which is OpenTelemetry distro with OpenTelemetry. I install all the dependencies, and I have one additional call, and this OpenTelemetry bootstrap will check into my Python environment, check every dependency, and check if there is an OpenTelemetry related dependency. And that's the reason why on Python, actually, which is the pricing, I get stuff that is related to the database. Connect, look, I connect to Postgres. I never coded that. Why? Because there is, in one of the OpenTelemetry packages, something that will sniff the SciCog2 calls. So it will intercept those calls and say, oh, look, that's cool. You are connecting to Postgres. And then you have everything that it does. It will select the catalog version. Catalog not as in e-commerce, but the catalog as in the database sense. And then it will select the current schema. And then it will show the transaction blah, 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 up until it gets me the exact SQL that is sent to the database driver. Cost for the developer, 0. I did nothing. I just added the dependencies, and even then, I just sniffed them. How cool is that? For the few people who know Java, this is the exact same stuff. And in the Java world, same stuff. In the POM, there is nothing OpenTelemetry related. What I did is in the Docker file, I just added the agent so that when I run the Java process, there is this Java agent stuff running. And again, the developer is completely oblivious about what's happening. I need to be a bit, well, I have 18 minutes, that's fine. Please, if you have questions, I will be happy to answer. Yeah.
What is the performance cost of intercepting at the record?
Thanks. So the question is, what's the performance cost of intercepting? And the answer is, it depends. It depends on your infrastructure. It depends whether it's synchronous or asynchronous. It depends on the library, on the SDK, on the tool. Now I have one question for you. What's better? To be very, very fast and don't know where you are going, or to be a bit slower and have visibility over the road? As a driver, as a car driver, what would you prefer? It depends. It depends. Now I will ask you, it depends on what? No, your question is sound, but the thing is to quantify exactly. It must be done in your environment, on your infrastructure, and in your tool, because depending on the stack, it might be widely different. Most of the time that I've seen is that it's asynchronous. So basically, it's just a thread running in the background. I saw recently a guy who did this, the measurement in Go, on Golang, and it was about like 5% of CPU higher, because it's not only about performance, like how slower it is, it might be also about resource consumption. But again, really, when you try to go this way, you must really account for what's worth my visibility into my stack. Yeah, sorry?
Fair enough.
Yeah, fair. Okay. Okay, let's do a bit better. So what I'm doing now, I will add the Kubernetes instrumentation because I'm running on Kubernetes and I would like to have additional data about what I'm doing on Kubernetes. So what I'm doing is I will deploy the second version of my app, which basically is just the following. I have this instrumenter here. So I am deploying an additional Kubernetes object which will create a hook. So every time you deploy a pod, it will be intercepted. And depending on certain parameters, it will do stuff. Also, what I added, and I need to find it because I don't find it anymore, is here. 3 lines, presets Kubernetes attributes. Now, because here the recommendation, so the recommendation is something that is not instrumented, I can show it to you afterwards, so I will kill it so that there is a chance that the hook starts. Sometimes this one doesn't work, so let's see. I will. Bless you. Okay, now I will again search. Yes, recommendation is here. Okay, so now what we have, I added 3 lines of code into my values.yaml in my Helm chart, and magically, I've got additional data that is related to Kubernetes. I've got the cluster name, the container name, the deployment name, blah, 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 blah. 3 lines of YAML. It's not bad. But more importantly, I got this recommendation component instrumented. So if you remember, or if you don't remember, I can show it to you. Here, there is no recommendation stuff. Okay? And now I have the recommendation stuff. Recommendation, what does it look like? So remember the trick? The trick is to put the instrumentation in the Docker file, right? Okay? And the Docker file is free of any OpenTelemetry dependencies. Oh, but you put it in the pyproject.toml. Not at all. So imagine I have this app which runs in a pod that is not instrumented at all, but it's still part of the distributed trace. Magic. So what's the trick? The trick is quite easy. I showed you the instrumenter, so this is a dedicated object that is operated by the OpenTelemetry operator. And here, what I just did on the recommendation side is this line. This line is enough to create spans in these components. Of course, I don't have a lot of control over it. It's just basic stuff. But still, it gives me enough to understand how the flow of the trace goes through all the components. When I deploy this pod, it's sent to the validation webhook, whatever, and then it's instrumented, and it returns me a pod that is slightly different than the pod that was to be deployed. Here, you can see that I'm able to instrument when I get the request, and again, I've got some information about the database request that I'm making. And this is really zero instrumentation, right? Nothing. Your developers don't know about it. Your ops people don't know about it. Only the Kubernetes administrator might know about it. So it's very cost effective. And it's a good entry point if you want to start OpenTelemetry. We can do better. Now imagine we want to have more control over the things. So now we say, okay, dear developers, now we will bother you a bit because, well, we need more details into what's happening. So in that case, what we can do is, I will deploy it, otherwise I will forget, and it will be a mess. Here in the pricing, what we can do is we can add in the pyproject.toml the OpenTelemetry distro. So now we can use the API, or at least the annotations. So here I have artificially split this route into two functions, and one of them I annotated. So here, this will be used by the runtime to say, oh, here I need to start the span. And the span names will be the name of my request. So I can say anything here. It might not be what is really running, but here I wanted to have fun. So if I curl again, so now we'll curl 3. Just want to be sure it's this one, yes. So here, you see, I have this select star from prices, blah, 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 blah. It's a bit small, but I'm not sure I can make it bigger here. So you can add additional spans as long as you can add an annotation to the method, which might not be what you want, right? Sometimes you have a method, and here I artificially split it, which is stupid. So perhaps you just want to use the API. That's what we are going to do here. So it's still the same dependency, but here I'm using the API and not only the annotation. So here I explicitly create a span that is named like this. Because now I have the full power of the API, I can pass additional attributes like product ID. One of the issues I can have is, imagine there is a mismatch, I don't get the correct data. So basically I'm having an issue because, I don't know, I ask for a product, I ask the catalog about product ID 1, I don't get the correct price, so I might think, oh, perhaps the catalog is not calling one of the components, especially the pricing one with the correct product ID. So I can add additional attributes. So if I make another request, I will need to kill the, I will need to kill the cache because here it doesn't work, there is no product for, and here there is the cache. So you won't see it, but I can show you on the catalog side. Not 30, 40. 40 is better. I have added an additional data point so that here I'm telling it I want to have the product ID, not this one, not this one. Where is it? It should be product ID somewhere. It's not here. I don't find it. It's here. No. It's here. No, there should be a product ID somewhere, believe me. I just don't find it in the span. It's fetch, of course. Sorry, product ID is 1. And then on the pricing side, you can check that the product ID that the catalog requested is same product ID that was requested on the pricing side. Now comes the last part, asynchronous messaging. So I mentioned that everything is forwarded through the HTTP header. So how does it work with asynchronous messaging? Well, in that case, you need to use the API yourself. So for example, so sorry, I have it on the Java side, but I think it works as well for you. So I'm still using the Java agent, but additionally, I'm using like the power of the API. So I'm using the OpenTelemetry API. So I have the service, I put a filter. Every time the filter is called, so at every request, it has an analytics filter kicking in. In this analytics filter, what I'm doing is I am creating myself the HTTP header, and instead of sending a request through HTTP, I use it as a metadata in the message. If you are on a lower version of MQTT, for example, there is no metadata. Well, you just make it part of the payload. It's less clean. It pollutes your message, but it still works. Here, I'm using version 5, so I can use metadata. And basically, I create the payload with data that you don't care about, but more importantly, I put the metadata inside. And then on the, remember the, this, on the Node.js side, I subscribe to the queue, and I do the exact opposite. Basically, when I receive the message, I will pass the payload. Again, we don't care, but I get the user property, basically the metadata. And out of the metadata, I'm able to extract the trace ID and the span ID. And here, I will actually create an active context out of it. And that's done. And now I used the API to get the tracer, to create the span, and to end the span. And now, ladies and gentlemen, here, you can see that I have this analytics component that is part of the trace. I'm not saying it's a good idea. One thing that can happen is that since it's asynchronous, like your synchronous stuff, well, I will do it for you, starts here, it ends here, you put the stuff in the queue here, and 2 hours later, it's read. And now your trace is squashed on both ends. So depending on your software, for example, here I can say, oh, this has been very interesting, I will check that. So you must also take into account how you will access the data. Through a GUI, a graphical user interface, or through some kind of other software. This is how you do it. And now I have 4 minutes, so I will leave it for the question. If you are interested in me, you can follow me on Mastodon or on Blue Sky. I think that Twitter, as you can see, is a bit dying, if it's not dead already. If you are interested in the source code, everything is on GitHub. It's just under a bit.ly link, so I can check how many people do actually click. Not many. If there is one, I'm happy. And now you have 3 minutes for questions. No question? No. Oh, yes, sir. Sorry, I will come a bit forward because at my age, you know.
So in your example, you created a child span within async process, but OpenTelemetry also suggests to use links for async processes. Any recommendations for when to use links, when to use?
No recommendation. As I mentioned, it really depends what you want to have. If you have a very short synchronous plus a long time in the queue and then again synchronous, nah, it doesn't make a sense. How you need to think about how you will want to use this data, and then you will have your answer. If you want to have everything in one stuff because you want to see how it works, nah, then it's good to have everything part of it. If it's completely unrelated and it's okay to have those two different pieces of data side by side, then use the second. Thanks. Other questions? Yes?
So in zero code approach, can I somehow filter out the data I don't want?
So the question is, in zero code instrumentation, can you filter out data? Yes, you can. only tell you about the Java agent because I really followed it from the beginning. In the version 1, they instrumented a lot of stuff by default, and then you had to filter out stuff that you wanted filtered out. In the second iteration, they have the basics minimum. It depends on the framework, actually. The Java agent caters to many, many different libraries. You can still filter out, but there is much less need to filter out because there is a chance you will have, like, at the beginning, you had 2 spans on the catalog, including the Postgres one. So, yes?
So this, I'm a beginner in this OpenTelemetry, but I was using Zentry, which does have traces as such as those. But I'm thinking about, this collector, can it also collect logs and other metrics?
So the question is about the OpenTelemetry collector. The OpenTelemetry collector collects metrics, logs, and traces. But again, it's bezplatno. But, I speak good Polish, right? That's one of the first words that you learn in any Slavic language that works across all of them. Platit, bezplatny. You must understand it's just a proxy. So you can't use it to store. You use it to process, enrich, filter out, aggregate, split. But yes, it can do a lot.
Yeah, I understand, because in the Zentry, if you don't have a collector, then it has to send this data directly to the server, which automatically increases the request time. But if there is a collector, then it can go just do this in the background. Right?
Yeah, exactly. And as I've shown you, you can have multiple collectors. Here I had 1 collector per nodes, but you can even have 1 collector after another collector, depending on what you want to do. And now I'm done. Thanks a lot. Have a good day. Enjoy the rest of the day. It was nice to be here in Krakow. And yeah, you can leave. Don't worry. Yeah, I can talk for hours.